Hello and welcome to another session, Physics. In this session, we will be looking at motion in nature. Motion in nature. But before that, let us review the previous lesson. Welcome back. Now let's try to define what we mean by motion in nature. When we talk about motion, we simply change in the position of a body from one point to another. We want to see how this body changes with time. That's what we mean when we talk about motion. How you move, say, from point A to point B. When we study motion too, it also involves how things move. In other words, the reason behind it and what makes them to move. We have two branches of motion. The first one is kinematics, and then we have the second one, dynamics, as you can see from the slide there too. When we talk about kinematics, we're simply describing how objects move without regard to the forces that cause their motion. In other words, we're only talking about how an object is moving. Is it moving linearly in a straight line? Is it moving perpendicularly? Is it moving at an angle? So we only are concerned about how they are moving, where they are going to, but we're not concerned about what is actually causing them to move. Is somebody pushing them? Are they under the influence of some force? And this is where dynamics comes in. Dynamics does not just talk about how objects move, but it also deals with why objects move the way they do. So it talks about the force behind objects moving. We have different types of motion, which we're going to consider now. The first one is translational motion. But what do we mean when we talk about translational motion? Translational motion simply refers to a motion that is performed, say, from one point, which is A, to another point, which is B. For instance, your mom sends you to go buy something at a shop opposite your house. That is translational motion. Let's say, for instance, you travel from Gambia in your state to another point, from your house for instance, to your, that's translational motion. From the church to the market, that's translational motion. For example, an aeroplane flying from Abuja to Lagos in Nigeria, for instance, that's an example of translational motion. The second type of motion we have is oscillatory motion. When we talk about oscillatory, we mean a repetitive kind of motion, a body moving to and fro, a body that is vibrating about a fixed point. Think of it as hitting a nail into a wall. Let's say this is a wall, and then this is a nail you hit into the wall, and then there is a rope coming down here, and on this rope is a simple ball. This more looks like the physical pendulum you're seeing on the slide here. Now, when you just pull this rope, let's say to this point here, you notice that it moves like this, and then it comes back like this, and it comes back like this. It keeps oscillating about this fixed central point. Examples of this principle are found in things like a guitar string. When a guitar string is low, that vibration causes that sound, that beautiful melodious sound that we hear. Practically in physics, we have the motion of a simple pendulum, as you can see from the slide here, as it swings back, forward. This movement is repeated after some time until it comes back to the center here, and then it rests. We also have the vibrations of the molecules of a solid. A third kind of motion is random motion. So that you must have seen smooth particles. Or most times when you're sweeping your school, for example, or sweeping your house, you tend to see dust particles. But what can you say about the motion of these dust particles? You say that they move in a zigzag direction continuously. They do not trace any definite path. They continue to move in irregular kind of motion. You can't describe what their motion looks like. We also have things like cloud particles. Already we've mentioned dust and smoke. they exhibit random motion. So random motion simply refers to a zigzag kind of motion, an irregular kind of motion, such as water, smoke, dust particles that have been suspended in the air. And that's where we have something like Brownian motion. Brownian is one good example of random motion. The fourth kind of motion we have is the one we call rotational motion. I'm sure you're familiar with this sort of motion. It simply means something moving around in circles. Can you think about things that move around in circles? The clock in your house, the earth about its axis. What about the fan in your house? What is its movement? The electric fan, of course, it rotates. What about a tap? When you go to the tap to fetch water, when you want to put the tap on, how does it move? Of course, it moves around in circles. So these are examples of rotational motion. We also have another unique, special kind of motion, and that's relative motion. Relative motion simply has to do with the motion of two bodies that are moving in a straight line relative to each other. Have you ever been in a car? You try to look out the window, and then there is a phenomenon that happens. It looks like the trees are moving as well. Some houses, it's as if these houses are also moving with you as well. When you look down on the road, it seems as if the road is also moving as well. Well, you and I both know that none of these things are moving. The only thing that is moving is and you inside the car. But these things we mentioned, the houses, the road itself, the trees, they possess relative motion. Now, on the same way too, when you have like your car is moving and another car is trying to overtake you guys in the car as well. When you're looking out from the window and you're staring at that car, it's as if that car is moving with a very small velocity. Well, the reason is because your car is already moving. Your car is also in motion. So there is a relationship between your car and that car as well. So let's try to consider some unique examples. Let's say, for instance, a car is traveling at a speed of 100 kilometers per hour, and then there is another car traveling with a speed of 60 kilometers per hour as well. And the funny thing is that both of them are moving in the same direction. I'll try to use the longer arrow since they are both vectors. Velocity is a vector, and both of them are not the same. So 100 kilometers per hour for one, and then 60 kilometers per hour for the shorter one. Now, if both of them are traveling in the same direction, it's going to be the velocity of the bigger one, 100, minus the velocity of the smaller one, 60, and we're going to have 40 kilometers per hour. That is their relative motion. But what if both of them are going in opposite direction? Let's say this one is 100 kilometers per hour, this one is going in this direction, the right hand side, and this one shorter, 60 kilometers per hour. Both of them are going in opposite directions. How do we calculate their relative motion? It's simply going to be the bigger minus the plus the smaller velocity. You add the velocities together if they are moving in opposite directions, and that's going to give us 160 kilometers per hour. And that's it for relative motion. Now let's look at things that cause motion, causes of motion, and that's dynamics this time around. When we are talking about things that cause motion, of course we know that force causes motion. When you keep your book on your desk or on your table, that book is going to remain at rest unless somebody comes there and removes it, or that book is pulled by an agent, for instance, wind. So we say that such an agent or change tends to the state of rest or of uniform motion of that body in a straight line, and that thing is called force. Footballers playing football, when someone passes the ball will continue to move in a straight line until it is acted upon by an external force. Either an opposition player intercepts the ball and changes its direction, or the ball comes to stop by itself as a result of what we call air resistance. Now let's look at the different kinds of forces we have. We have two main kinds of forces. We have contact force and we have force fields. Under force, we say that these are forces that exist between two surfaces in contact. We have two main kinds of contact forces. They are push and pull. Push and pull. These are the two main types of contact forces. I'm sure you must have been to an eatery, a restaurant, a shop, and then you'll be asked to either push the door or pull the door. So you can see from the pictorial illustration here, pulling has to do with bringing towards yourself, pulling it towards yourself, whereas pushing is away from you, the pushing away from you. Other contact forces include frictional forces, reaction and tension forces that occur in strings and wires. On the other hand, force fields are those forces that do not require close contact with anybody to which they are applied. For instance, when you jump up, you know definitely that you're going to come down. You're not just going to keep going upwards. What is it that is pulling you down? Force, gravitational force. Nobody is pulling you down, but a force pulls you down. That force does not need to hold you before it pulls you down. Examples of force fields are gravitational force fields, electrostatic force fields, we have electric force fields, and then we have magnetic force fields. Now let's look at circular motion. Now, circular motion has to do with things such as the moon circling the earth, we say orbiting. We also have planets moving around. We have the earth moving around the sun, which is a revolution. And then we have stones that are tied to a string and they are whirled in horizontal, vertical circles. Circular motion has about 3 characteristics. The first, they have constant speed, they have changing or variable velocity, and they have what we call centripetal acceleration. Now, let's look at what these things mean. Where we are talking about centripetal force, we simply mean that force that is required to keep an object moving with constant speed in a circular path by pulling it inward. Sometimes when you're on a bicycle and you want to turn round, the body tends to move inwards. That's centripetal force pulling you in. And at that point in time, the acceleration that body possesses is what we call centripetal acceleration. The opposite of centripetal force is what we call centrifugal force. The opposite of centripetal force is what we call centrifugal force. Centripetal force pulls you inwards, but centrifugal force tends to pull the body away from the center. And you can see their formulas here. Centripetal force is mv squared, that is mass times velocity squared divided by the radius. On the other hand, centrifugal force is minus mv squared, so it's the opposite there. Thank you for us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on the screen.